In our lesson today, we are going to look at analyzing graphs of functions, essentially looking at a graph and being able to answer questions about the data as presented. So our learning goal is to be able to interpret the graph of a function in context without using an equation. Let's get started. The graph of a function on the right shows us the temperature between noon and midnight in Danbury. Based on the data presented, let's look at how to answer the following questions. At this point, you might want to pause the video and attempt to answer each of these questions on your own. When you are finished, resume the video, and I will show you exactly how to go about answering each of the questions. Let's take a look at the first question. Was it warmer at 3 or 9 p.m.? We find 3 on the x-axis because that represents 3 p.m. We find 9 on the x-axis because that represents 9 p.m. We go across to the y-axis to find the respective values. For 3 p.m., 54.5 would be a good approximate answer. For 9 p.m., 55.5 would be a good approximate answer. So, was it warmer at 3 or 9 p.m.? 9 p.m. would be the correct answer. Let's take a look at the next question. Approximately when was the highest temperature during the period? Here, we're going to go to the very highest peak on our graph, and we see that the highest temperature is found at 59 degrees. So 59 degrees is the answer. Let's go to the next question. Find another time when the temperature was the same as 4 p.m. Here we want to begin by going to 4 p.m. and then looking across the graph to find any other time on our line that has the same temperature. We see that there is one other point that has the same temperature as 4 p.m. and if we go down to the x-axis, we can see that the answer is 8. So the other time that has the same temperature as 4 p.m. is 8 p.m. Let's go to the next question. Did the temperature change more between 1 to 3 p.m. or 3 to 5 p.m.? First, we start by finding our time periods. The first one is between 1 and 3 p.m. So we find 1 on the x-axis and go up to the line for our function. Then we go to 3 p.m. and go up to the line on our function, and we can find the appropriate y values. So for 1, it's approximately 50.5, and for 3, it's approximately 54.5. We subtract the 2, and we see the difference between 1 and 3 p.m. is 4 degrees. Now we do the same thing for the 3 to 5 time slot. We already have a dot showing us 3 p.m., so we go up to the 5 p.m. slot on our time and go up to the line of the graph. And there we see it's approximately 58.25. So again, we subtract 54.5 from 58.25, and we get 3.75. So, did the temperature change more between 1 and 3 p.m. or 3 and 5 p.m.? The answer is 1 to 3 p.m. Onward to the next question. Does this graph show that the temperature is a function of time or time is a function of temperature? A good way to think of this is which one is dependent on the other. Is the temperature dependent upon the time, or is the time dependent upon the temperature? Because the temperature is dependent upon the time, the temperature is a function of the time. And finally, let's take a look at the last question. When the input of the function is 8, what is the output? The input of the function, which is the independent variable, is shown on the x-axis. So we go over to the x-axis and we go up to find where that intersects with the line for the graph of the function. And we can see that that is 57 degrees. So when the function is 8, what is the output? About 57.